Hi everybody, Patrick here from www.electroniclessons.com and www.engineeringshock.com. This project is, what it is it's a capacitor charger, a supercapacitor charger, and it charges your capacitors to 2.5 volts, or 5 volts, or 10 volts, or 12 volts. Now the reason I did this was because if you're charging supercapacitors, you never want to charge to a never want to overcharge them. You can keep them charged at the same voltage. So if it's rated for 2.5 volts, you can keep 2.5 volts. Just charging it. Once it's taken in 2.5 volts worth of charge, it won't accept any more energy. But a lot of the time, you want to supervise them with a multimeter, and this takes that out of the equation. What I've done, if I break down this circuit into a block diagram, this is my 15 volt supply regulator. 5 volt regulator for digital. The 15 volt regulator allows me to make four different analog voltage points that are adjustable through these potentiometers. 12 volts, 10 volts, 5 volts, and 2.5 volts. Now those are fed into op-amp comparator circuits. Over here, this is the charge circuit. I got my series power resistors, my two blocking diodes. Here's the brain circuit that includes a PIC 18F1220, some indicator LEDs, the selection button, the reset button, a piezo buzzer. This is my display that displays the charge on the supercapacitors, and there's a 9 volt regulator. So anyway, what I'll do is I'll plug it in. I need to add a switch and I need to add labels to these LEDs, but I'll plug it in. So there's essentially absolutely nothing at the charging output. So what I do is, if I want to charge to 2 volts, I will press this button once and it will light up this LED, which indicates 2.5 volts. If I press it again, it'll go to this button, which indicates 5 volts. Again, 10 volts and 12 volts, and then it resets back to 2.5 volts. So what I've got here is a 20 farad 2.5 volt capacitor. So what I'll do is I'll put it in. I'll put it into the charge output. And it says we got about 320 millivolts on it. So I'm going to choose my 2.5 volt charge. And I'm going to start. That's my indicator saying, okay, charge is about to commence. Relay turns on. Capacitor starts charging. So at around 2.5 volts, the charge will stop. No power will be going to the supercapacitor, and I will be forced to reset. The indicator buzzer will buzz a few times more, and then it'll force me into reset. So it'll actually, since it's charging so fast, this is a relatively small supercapacitor, a big capacitor, but a relatively small supercapacitor. We sell supercapacitors ranging from 1 farad to 2600 farads. So as you can see, we're almost at 2.5 volts. Let's just watch. So it charged up to 2.49 volts. So what I'll do is I will reset. I will take out my now charged supercapacitor, and I will put it into whatever I want to power. So next, what I'll do is I'll do a 5 volt charge. I'll just stop the video and do another setup. Okay, so now what I've got here are two 20 farad capacitors in series, so 5 volts at roughly 10 farads. So what I'll do is I will choose my 5 volt setting, and I will commence charging. As you can see right now, there's 2.86 volts in the series bank. 3 beeps to indicate charging is about to commence. Charging commences. So that's going to go up to roughly 5 volts, give or take about, hopefully, about 10 millivolts or 100 millivolts. It's going to take about 5-10 more seconds for it to fully charge. So it stopped at 4.96 volts. Now these are fully adjustable. I can change these values and finely tune it. So once it stops charging, it dips a little bit, but it'll actually stop. It happens with all supercapacitors. So what I'll do is I'm going to reset, take out my supercapacitor bank, and I will show you my big supercapacitor bank. Okay, so now I'm going to put it to my 10 volt setting. What I've got here is my trusty 12.5 volt 96 farad supercapacitor bank, which is actually on sale on eBay. It's been treated very, very well. It's custom made by me. So anyway, right now, since it's going to we're at roughly 100 farads, it's going to take slower to charge. So right now, as you can see, there's 9.37 volts on it. So I'm going to choose my 10 volt setting, 3 LEDs, and then I will press charge. 1, 2, 3. Charge commences. So when that hits 10 volts, we're going to see exactly what we saw with the other ones. It's going to stop charging. It's going to say, "Hey Pat, beep beep beep. We're done charging. Your supercapacitor is ready to do awesome stuff with." Now keep in mind, if you've seen some of my other videos, you've known that this bank specifically has powered my TV. It's powered my bass amp. You threw an inverter. It's an awesome bank, and we're charging it relatively quickly. Now, this circuit requires a lot of power. I mean, not necessarily for the onboard circuit, but since these supercapacitors are taking so much energy, I really have to use a huge, bulky. I've actually used my Bose audio player power supply for it that can output 18 volts DC at 1 amp, and I'm really driving it to the max with this circuit. But it works perfect. We got to make sure that when it's charging the supercapacitors, that it's actually not there's no significant dip at the voltage, because we need a 15 volt output for a 15 volt regulator, 9 volt output for a 9 volt regulator, and 5 volts for 5 volt regulator. And if you don't have enough voltage at the inputs because of a drop, your circuit isn't going to work right. So we're almost there. We're almost to 10 volts. Now it's going to give or take. It's going to give or take a little bit. But this capacitor, there we go, 10.02 volts, and then there's our drop, our slight drop in voltage that happens. Perfect. It's charged to 9.94. So what I'm going to do is I'll reset it. Everything is good. Now what I'll do is I will charge this to 12 volts, and I'll stop the video because it's going to take a few minutes to charge to 12. That's actually at 12 volts. So what I'll do is I'll bring this to 12 volts. 2, 3, 4. 1, 2, 3. I realize it's kind of redundant at this point, you know, but I want you to know that what I can do is I can literally change the values using these potentiometers. And this is what this is going to do is I'm retrofitting a lot of electronics with supercapacitors these days, because if you treat them well, like this, I'm always making sure to not overcharge them. They can live longer. These supercapacitors, if treated well, will live longer than me. They'll live longer than you. They'll live longer than your kids, God forbid. Anyway, so what we're gonna sorry, I realize that's a little bit morbid. Anyway, you know, I mean, excellent form of green energy. You can hook them up to solar cells. I've actually got some 2600 farads behind me, supercapacitors behind me that are currently being charged during the day by some solar panels that I've super glued to the window. Much to my lovely girlfriend's dismay. Anyway, what I'll do is I'll stop the video now, and I will resume when it hits 12.5 volts. Okay, so in previous tests, as you can see, we're almost at 12 volts. I think it actually went off at around, what was it? About 12.05, or anywhere from 12.05 to 12.2. That's when it stopped charging. Now this, again, this is configurable using this specific potentiometer. You have to fine-tune the entire circuit. But the reason I didn't use normal resistors was because they don't make values that are exact, not at least cheaply, not a 1% tolerance. So this worked out really, really well. Now it's going to go off any second, and that will conclude the video. But right now, there's a comparator circuit that has the common voltage. Every comparator circuit at the negative input has this voltage on it. There we go. Fully charged. This capacitor bank is, I never charge it past 12 volts, even though it's rated for 12.5 volts, because You want to treat your supercapacitors with respect. Anyway, there's 4 comparator circuits here. Each of them at the positive input has a different voltage reference: 2.5 volts, 5 volts, 10 volts, and 12 volts. And all of the negative inputs are tied together and are tied right here. So when the voltage at the supercapacitor surpasses those voltages, depending on which setting you have it on, it'll deactivate the charge and tell you that, you know, through the use of the piezo buzzer and the charged LED, up, charged, you're ready to go, fine and dandy. And yeah, so I'm really quite happy with this project. Let me just show you inside. What I'm going to do is I'll unplug it. I have to add an on-off switch. I'll unplug it. Nothing special inside, just a big power supply. And that's my video. So, supercapacitors, come on, ask me any questions. I'd love to answer them. I've got an Instructable. If you go to Instructables.com, search supercapacitor charger. Come on, come all, ask questions. Got lots of supercapacitors for the best prices on eBay. Thanks, guys.